Hello grade 8s, this is Mr. Miller and welcome to lesson 10.2, which is all about modeling and solving two-step equations. Now hopefully you've got your lesson notes in front of you right now, and hopefully you're not freaking out over the fact that there are 12 questions on the first page, because actually I'm not going to do all of those. I'm only going to do 3, one from number 1, one from number 2, and one from number 3, so part A from each one. And let's get straight to number 1, which is where we're looking to draw balance scales and blocks. Balance scales and blocks to represent each equation. And then we're going to solve. And I'll show you the website that I use to make these representations. It's a really cool website. You can get to it by typing into a browser bit.ly/1E3 It takes you to the National Library of Virtual Manipulatives, specifically this algebra balance scales with negatives. It's got some instructions on the right that you can read here, but I'll give you a quick demo. Here we have positive 1, positive 2, positive 3, positive 4, positive 5, however many you want to stack up. I'm not sure if there's a limit there. Anyways, if you put on too many, you can always put them into the trash, or you can clear them all out at once. In addition to the positives, which weight a side down, you've got these negatives that pull up. And notice that a positive 1 and a negative 1 balance each other out. You also have some unknown masses. So there's an x and a 2x and a 3x and so on. And then you have these negative x represented by these kind of like helium balloons. And notice that a negative x and a positive x also balance each other out. So I do recommend that you play around with this website. It gets you really familiar with this particular model, and it also gets you some great practice with solving equations. Anyways, let's get back to the lesson notes here, and we want to draw these balance scales and blocks to represent each equation and then solve. So in part A, drawing a balance scale set and blocks to represent this equation, we want to have 2x plus 5 equals 9. So notice here we have two unknown masses, x plus another 5, balancing out with 9. And ultimately we want to get to a solution which is x equals something. So what I'm going to do is I'm going to remove 5 blocks from the left, and I'll also remove 5 blocks from the right. That's equivalent to algebraically subtracting 5 from both sides and getting 2x equals 4. Then from each side of this balance I want to split it in half. So that's equivalent to dividing both sides of the equation by 2 and ending up with this x equals 2. Well, that's the solution. And if you take this x equals 2 and you plug it back into the equation, 2 times 2 plus 5 is equal to 9, right? 2 times 2 is 4, and 4 plus 5 is equal to 9. So you know you have the right solution here. That's a little informal check that I've just done there. So that's that particular model. We do have another model that we're going to look at now, which is drawing algebra tiles to model the equation, and then we're going to solve. So in part A here, if I want to model this equation, 3x minus 2 equals 7, I start with 3x tiles and then 2 negative 1 tiles on the left side, and then 7 positive 1 tiles on the right. Now if I want to solve and end up with just x equals a number, then what I need to do here is I need to add positive 2 to both sides. So that's equivalent to adding 2 to both sides of the equation. The reason we do that is because we end up with just 3x on the left and 9 on the right. So this is one step closer to having a solution. Notice the symbolically it looks the same. We're getting close to just having just x equals and a number. And finally, if we split into 3 equal groups here, which is equivalent to dividing both sides of the equation by 3, we end up with the solution just a single x being equal to 3, and that's symbolically what it looks like. You can do a little informal check here. If we take this x equals 3 and think about putting it in here, 3 times 3 is 9 minus 2 is 7. Yeah, that's the right solution. So now those two models are lovely and everything, but it's time consuming and space consuming to do those diagrams, right? So if it says solve, really the most efficient way to solve, I mean, if you can do solve by inspection, that's awesome. But using the method of inverses will allow you to show your work first of all and get full marks. And also it's a very reliable and it's a very quick method to do. So that's what we're going to be looking at here before we do our check. So looking at this equation, we've got 5 times some number plus 3, and that's supposed to be 23. And maybe some of you are able to come up with the answer for what t is right off the bat because you're good at solving by inspection. Awesome. Regardless, we want to think about how do we solve by the method of inverses, because it is a really efficient way to do it. So think about what you're doing to t. Well, we're multiplying it by 5, then adding 3. Multiplying by 5, then adding 3. What's the inverse of that? Well, we have to go in the opposite direction and do the inverse of each operation. So first we're going to subtract 3 and then we're going to divide by 5. Let's see what that looks like. Subtracting 3 from both sides leaves us with 20 on the left and 5t on the right. Then dividing both sides by 5 leaves us with 4 on the left and t on the right. T equals 4, that's the solution. So that's the solve part. Now we have to check. To do a proper check in solving after solving an equation, what we do is we start with the original left-hand side and the original right-hand side of the equation. We replace the variable with what we think is the solution, and then we calculate. If both sides are equal, we know we have the right solution, and that's certainly the case here. So now question number 4 is just more practice with doing checks. So when it says show whether x equals 6 is the solution to each equation, they're asking us to do a check. Don't just solve it and see if x equals 6 happens to be the solution. I really want you to show you a check. So in part A here, here's what we're going to do. We're going to start with the original left-hand side and right-hand side of the equation. We're going to replace the variable with what we think might be the solution, and we're going to calculate. If the left-hand side and right-hand side match, as they do here, you know you have the right solution. If you don't, then it is not the correct solution of that equation. Last part of this lesson, we want to do a word problem. So now, just a little reading strategy for you. First thing I recommend to do is read the entire question. Let's do that together. In a recent football game, the Spartans scored 47 points. This total included 4 field goals, which are worth 3 points each. The rest were converted touchdowns worth 7 points each. We want to write and solve an equation to find out how many converted touchdowns the Spartans scored. Now, if nothing else, you should be able to do this. Declaring the variable that you're going to use in solving this problem. So we are supposed to write and solve an equation to find out how many converted touchdowns they scored. So let t be the number of converted touchdowns they scored. Everybody should be able to do that. Declare what the variable is that you should be using in the first place. Next, you want to write an equation. Now, to write the equation, I'm going to give you a little bit of extra. You don't need to necessarily write this part down, but I just want to point out something. That in terms of the total number of points that are scored, and we know that the total number of points is 47. We know there's 2 pieces to that. It included the field goals, and it also included these converted touchdowns. So there are 2 pieces to this adding together to get the total number of points. Well, the field goal part, there were 4 field goals worth 3 points each, so that's 4 times 3. The converted touchdowns, we don't know how many converted touchdowns they are, but we know they're worth 7 points each. So 7 times the number of touchdowns would give you the total number of points for converted touchdowns. add these two pieces together gives you the grand total number of points, which was 47 for that game. So now you can simplify that equation a little bit by actually doing that multiplication. 4 times 3 it gives you 12. And now look, this is exactly the kinds of equations we've been solving in this particular lesson. So now use the method of inverses. Look at the variable and say, what are we doing to this variable? Well, we're multiplying it by 7 and adding 12. So what should we do? Subtract 12 and then divide by 7. And here's the solution, t equals 5. Once you have that, you should write a full sentence answer. Before you do that, I do recommend that you go back and reread the question, make sure that you're answering it properly. Find out how many converted touchdowns Spartans scored. Okay, so the Spartans scored 5 converted touchdowns. Notice that overall in the solution here, what we have is we have a let statement declaring the variable, we have made an equation, we've solved the equation, and then we have a full sentence answer. That's the kind of solution I'm looking for a word problem. So that concludes this lesson, folks. Hope that this all made a lot of sense to you. If there's any piece of it that was confusing to you, please don't hesitate to ask in class. And hey, you all have a wonderful day. Take care. Bye.